Welcome back everyone. In this video we're going to discuss squares and square roots. Okay, we will be discussing the properties of squared numbers. Now in the first part of the video we'll have already discussed the first three properties of squares and square roots. So if you haven't watched that video yet, please make sure you watch that video first and then you can come back to this video. Let's get started. The fourth property that we're going to discuss here is squares of even number or odd number are even and odd respectively. Okay, so what do we mean by that? We mean that square of even numbers will be even and square of odd numbers will be odd. Let us see some examples. Like for example, if you have square of 12, okay, we get square of 12 to be 144. Square of 14 is 196. So if you see square of 12, that means even number, is always even. Square of 14, which is even, is again even. Okay, but square of 17, which is an odd number, is odd. So to summarize, we see that squares of numbers that end with 1, 3, 5, 7 and 9 will end with 1, 9, 5, 9, 1 respectively. So 1, 1, 3, 9, 5, 5, 7, 9, 9, 1. You can look at the table on the left hand side of your screen. 2, 4, 4, 6, 6, 6, 8, 4, 0, 0. Alright, now let us discuss the fifth property. The number of digits in a square of a number with n digits is either 2n minus 1 or 2n. Okay, to understand this, let us discuss some examples. Let's say n is 1. Now we know n is nothing but the number of digits, so our number will have only one digit. Alright, now 3 square means 3 into 3 is equal to 9. Now this follows the first formula, that is 2n minus 1. So n is 1 here, so 2 into 1 is 2, minus 1, 1. Similarly, if n is 1, let's say 9 square. Now 9 square is 81. Alright, so it follows the second formula, that is 2 into 1 is equal to 2. Alright, you can pause the video and check for these substitutions. N equals 2, n equals 2, and n equals 2. These two, they follow the first formula, and this 2 follows the second one. Let us now discuss the sixth property. The square of a number is equal to the sum of that many odd numbers starting from 1. Okay, let us understand this with the help of an example. So 3 square, okay, so we'll have to add that many odd numbers starting from 1. So how many? 3 odd numbers starting from 1. So we know the odd numbers are 1, 3 and 5. So 1, 2, 3. Now 1 plus 3 is 4, 4 plus 5 is 9. Let's look at another example. 4 square. Okay, so how many odd numbers? 4. Alright, so 1, 2, 3, 4. Let's add them. So 1 plus 3 is 4, 4 plus 5 is 9, and 9 plus 7 is 16. Similarly for 5 square. So how many odd numbers? 5. So 1, 2, 3, 4, 5. If you add all these odd numbers, you get 25. Okay, so this is valid for all numbers like 6 square, 7 square. You can try this yourself. Okay, so in general we can say that for n square it will be 1 plus 3 plus 5 plus dot 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 till n. Okay, so up to n numbers, when you add, you will get n into n, which is n square. Let us now discuss the seventh property. The number of numbers between any two consecutive square numbers is twice the square root of the first number. Okay, let us understand this property with the help of an example. Let's say between 1 and 4. Now we know between 1 and 4 there are how many numbers? 2, 3. So there are two numbers between 1 and 4. Okay, so which is basically between 1 square and 2 square. Alright, so it says is equal to twice the square root of the first number. Okay, so twice the square root of the first number. Now first number is 1, so that means square root of 1. Now square root of 1 is 1. We will be discussing square roots in the upcoming videos. So for now, just remember that square root of 1 is 1. So 2 into 1 is 2, okay, which actually matches with the number of numbers between 1 and 4. Okay, let us understand this with another example. Let's say between 9 and 16, alright, that is 3 square and 4 square. So the property says there will be twice the square root of the first number. Now again, square root of 9 is 3. So 2 into 3 is 6. Okay, for now just remember that square root of 9 is equal to 3. Alright, so there should be 6 numbers. Let's count. Now between 9 and 16 there is 10, 11, 12, 13, 14, 15. So 1, 2, 3, 4, 5, 6. Okay, let us now look at some sample questions. Okay, so number one, okay, the question says observe the units digit and state which of the following are not perfect squares. Okay, that means we'll have to just look at the units digit, and by looking at the units digit we'll have to make out whether it's a perfect square or not. Okay, now let's see the first example. Number one, 4836. Okay, so if you remember from my first video, 4836 means the last digit is 6. So in order to get 6 as our last digit, its square root, or the number that is to be squared in order to get this, must end with 4 or 6. Okay, so we'll write, since the last digit is 6, that is 4 square or 6 square, 4836 may be a perfect square. Okay, now understand this, we write may be because it is not sure that it will be a perfect square. For example, 116. Okay, now you see 116 ends with 6. Okay, but its square root, or the number that is to be squared in order to get 116, is not an integer. Alright, that means there will be a decimal in the number. Okay, let us look at the second example, 3722. Okay, now since the last digit is 2, now again referring to my first video, property 2, we know that square of any number will not end with 2. Okay, the units digit cannot be 2. So we can very clearly say that 3722 cannot be a perfect square. Okay, number 3, 9867. Again, since the last digit is 7, 9867 cannot be a perfect square. Okay, so from these examples we understand that we can very surely say that this is not a perfect square. Okay, but we cannot be sure about the fact that it may or may not be a perfect square. Okay, please keep this in mind. Let us look at one more type of questions. Here they are asking us to write down the units digit of the following squares. Okay, so let's do number 1, 78 square. Now we know 8 square is equal to 64. Okay, so the units digit must be 4. So the unit digit of 78 square will be 4. Alright, let's look at the second one, 33 square. We know 3 square is equal to 9. So units digit of 33 square will be 9. Third one, 27 square. We know 7 square, the units digit, is 49. So the units digit of 27 square will be 9. Let us now look at one more property. State the number of digits in the squares of the following. So number 1, 72 square. Okay, so here n is equal to 2. Here we will be using the fifth property. Therefore, the number of digits in 72 can be, there were two formula, 2n minus 1 or simply 2n. So if you substitute n equals 2 here, then you get 2 into 2. That is, in place of n, we're writing 2. Now 2 into 2 is 4 minus 1. 4 minus 1 is 3. Or 2n. So if you substitute 2 here, then you get 2. 2 2s are 4. Okay, so the number of digits may be 3 or 4. Let us look at one more question. 4. Find the sum of the following numbers without actually adding. So this part is very important, without actually adding the numbers. Alright, so how will we find the sum without adding? Alright, now if you look at this question, number 1, it is 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15. So what do we notice in this question? First thing, all numbers are here odd. Okay, the second thing, we see that they are in sequence, that is 1 3 5 7 9 11. Okay, all of them are consecutive odd numbers, so we can apply the property. Okay, now here n is equal to 8, so 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 will be equal to 8 square. Okay, this is nothing but the property 6. Now we know 8 square is 64. Okay, if you didn't understand this, let us understand this with another example. Okay, so 1 plus 3 plus 5 plus 7 plus 9 plus 15 plus 17. Again, we see that these are all odd numbers and they are consecutive odd numbers. Alright, consecutive odd numbers. So we simply say here n is equal to 9. 1 2 3 4 5 6 7 8 9. So here n is equal to 9. Therefore, this sum will be simply equal to 9 square, which we know is equal to 9 into 9, so 81. Again, property number 6. Okay, I hope you have understood this sum. If you haven't, please rewind the video and make sure you understand the sum. Let us see one more problem. Number 5. Okay, express the following as sum of consecutive odd numbers. Alright, so this is similar to this problem, but we can say that this problem is reverse of this problem. Here we had been given the series and we had to find the sum, that is the number. But here the sum is given and we'll have to find the series. Alright, let's look at the first question. 7 square. So here n is equal to 7. Okay, why 7? Because it has already been expressed in the form of 7 square. So if you find the square root of 7 square, then square root of 7 square is 7. Okay, so n is equal to 7. Therefore, the series will be 1 plus 3 plus 5 all the way up to 13. There should be 1 2 3 4 5 6 7 terms. Okay, let's look at one more problem, a little different than the first one. 81. Alright, here 81 is equal to 9 square. Alright, so n will be equal to 9 because square root of 81 is equal to 9. Okay, therefore the series will be this. There should be 9 numbers. Alright, let us now see the last type of numerical for this video. Okay, state the number of numbers between 4 square and 5 square. So 4 square and 5 square, from here we know that if we have to find the number of numbers here, we have to use property number 7. So using property 7, we know the number of numbers between 4 square and 5 square will be 2 into square root of the first number. Okay, please recollect property number 7. So 2 into square root of 4 square. So 2 into square root of 4 square is 4. So 2 into 4 is 8. Okay, let's look at one more problem. 15 square and 16 square. So using the property number 7, we know the number of numbers between 15 square and 16 square will be 2 into square root of 15 square, that is square root of the first number. Okay, do not take 16 square, it will just be the square root of the first number. Okay, so 2 into square root of 15 square is 15. 2 into 15 is 30. Please practice as many questions as you can, and if you have any questions that you face difficulty with, you can drop it in the comment box. Thank you everyone for watching. I hope to see you in my next video. Take care everyone.